Okay, welcome back to Level Chemistry. Today we're going to have a look at redox reactions, but today what we're going to do is we're just going to work with equations. Now to me this really just is chemistry, and it's all about your understanding and actually not really very much learning. It's just, do you understand what types of particles you're working with and what happens to them during chemical change. Okay, so let's have a look at the first equation. I'm going to react a little bit of magnesium with hydrochloric acid. Okay, metal plus an acid is going to make a salt, magnesium chloride, plus hydrogen gas. Okay, then I need to balance that. Okay, like that. Okay, if I look at that, I'm starting here with a lump of magnesium, so that's made from magnesium atoms. Okay, so the oxidation state of the magnesium atoms is 0. Okay, in that equation then, those magnesium atoms, well, they form an ionic compound. Okay, so Mg then forms Mg2 plus ions, okay, which have got an oxidation state of +2. So the magnesium has gone from an oxidation state of 0 to +2, so therefore it's been oxidized. Now I'm looking for a species in that reaction that has been reduced. Okay, so if that's my oxidation reaction, okay, I'm now looking for a reduction reaction. Okay, so I have a look through here and I think, oh right, okay, HCl, hydrochloric acid. What makes a solution acidic? The presence of a hydrogen ion. So I've got some H plus ions there. The H plus ions are forming H2. Okay, so 2 plus 2 electrons. Okay, that is my reduction reaction. Okay, the oxidation state of the hydrogen ion is +1. The oxidation state of the hydrogen in the hydrogen molecules is 0. So the oxidation state has been reduced, hence that is a reduction reaction. Okay, I could have just written my half equation for that, couldn't I? Okay, Mg goes to Mg2 plus 2 electrons, like that. Okay, so there we have it. That's your first equation. Look at another one. Okay, this time possibly a little bit more challenging. MnO2 plus 4 HCl goes to MnCl2 plus Cl2 plus 2 H2O. Okay, let's have a look through that whole equation then. Okay, I was tempted to give that a name using its oxidation state, well, using the oxidation state of the manganese, but I resisted because that's what we're going to work out now. Okay, so let's have a go through this and look at all the oxidation states of all the different species. Okay, so 2 times -2 is -4. The overall charge on that species is 0, or on that whole compound is 0. Okay, so I've got to get from -4 up to 0. So something is contributing +4. Well, the only other thing that can contribute there is a manganese, so that must be contributing +4. So the oxidation state of the manganese is +4. Okay, let's have a look what happens to the manganese here then. Okay, it forms manganese chloride. Okay, well, the chloride ions contribute, they are Cl minus, and there's 2 of them, but it's Cl minus, so the oxidation, or sorry, the contribution from the chloride is -2. Okay, the overall charge on that whole species is 0, so therefore this manganese must be contributing +2. Okay, so my manganese has gone from Mn in a +4 oxidation state to Mn in a +2 oxidation state. Okay, so the manganese has been reduced as it has gone from a +4 oxidation state to a +2 oxidation state. Okay, so that's my reduction reaction. Right, let's have a look further through here then. And I'm looking through here, and I've spotted that on the other side of that equation there, I've got some Cl2. Okay, well that's molecular. It's all the same element, two Cl atoms covalently bonded together, so it's all the same element, so that must have an oxidation state of 0. And then I look through the equation here and I'm thinking, oh right, I've got some HCl, hydrochloric acid, which is a strong acid. So we all know that strong acids are acids that fully dissociate in aqueous solution. So H plus must dissociate from the Cl minus. Well, in there I've got some Cl minus. Cl minus became, going off the page there, Cl minus became Cl2. Okay. So the oxidation state of the chloride ion there is -1, so Cl minus. The oxidation state is -1. It went to Cl2. The oxidation state of that is 0. Okay, so going from -1 to 0, the oxidation state is increasing. So the oxidation state of Cl minus is increasing. Therefore, this is the oxidation reaction. Okay, so we can basically look at this and say that in that reaction it's a redox reaction because the manganese is being reduced from its +4 oxidation state to its +2 oxidation state, and the chloride ion here is being oxidized as it moves from the Cl minus ion to the molecular chlorine, so oxidation state of -1 to an oxidation state of 0. Okay, so that's increasing, so that's oxidation. Okay. Get rid of that. Right, the next thing we're going to look at then is how we combine half equations to get an overall chemical equation. Okay, so we're just going to have a look at one of these for now. Okay, and then we'll come back to this in the next part and do a little bit more. Okay, so if I take some MnO4 minus, okay, and I tell you that in my reaction that's converted into Mn2 plus. Okay, a good little thing to remember is that this manganate here, or permanganate, this manganate permanganate is a really nice purple colour. Yeah, you'll need to know that next year. But the Mn2 plus ions, they become colourless. Yeah, it's a transition metal, manganese, so you get a good bits of colour change there. Okay, right, okay, that's a different topic though. I'm going off on one here. That is, don't worry about that. Okay, manganate here going to Mn2 plus. First of all, I need to balance that equation. Okay, and I've got oxygen on that side of the equation, so I need to have some oxygen on this side of the equation, and I always do that in these half equations by adding water. So whenever you need to add oxygen to one side of an equation because it's on the other side, you always add water. Yeah, you don't even think about it, that's just what happens. Okay, and it works correctly every time. Okay, so how many oxygens have I got on that side? I've got 4, so I need 4 on this side. Okay, so then that suddenly creates 4 times 2 is 8 H plus. Okay, so I've got 1 Mn, 1 Mn, 4 O's, 4 O's, 4 2's 8, 8 H plus. Okay, now the next thing we have to do is we have to balance our charges. Okay, right, so on this side of the equation my total charge is 8 plus minus 1, so it's plus 7. 8 plus minus 1 is plus 7. On this side my total charge is plus 2. Okay, so remember that redox chemistry is all about the transfer of electrons, so I'm going to balance my charges by transferring some electrons somewhere. Right, so I've got plus 7 on that side, I've got plus 2 on that side. I need to go from plus 7 down to plus 2. So if I add 5 electrons, 5 negative charges onto that left hand side, yeah, plus 7 minus 5 takes me down to plus 2. My charges now balance. Okay, so let's have a little think. What type of a reaction is that? Okay, Well, let's have a look at the oxidation state of the manganese. Okay, so the manganese in this permanganate here is 4 times minus 2, it's minus 8. I need to get up to minus 1. Okay, so it's plus 7. So that's plus 7. Okay, the oxidation state of the manganese in the Mn2 plus there is plus 2. Okay, so plus 7 to plus 2, then that is a reduction reaction. Okay, focus that in a little bit. Oh, there we go, look at that. Learning every day. There we go, good stuff. Okay, so if that's a reduction reaction, that must be accompanied by an oxidation reaction. So I'm going to take some Fe2 plus, F goes to Fe3 plus. Okay, I need to balance that, don't I, with my electrons. So 2 plus on that side, 3 plus on that side. I need to get that 3 plus down to 2 plus. So if I add an electron onto that side, plus 3 minus 1 is plus 2. Okay, right, so I could write this, but I'm not going to worry about this too much, but I could write this Fe2 plus minus an electron goes to Fe3 plus. Okay, so Fe2 plus losing electron, that's your oxidation reaction. Okay, 2 plus minus minus makes a plus, so 2 plus minus minus 1 is 2 plus 1 effectively, which makes 3, and it's 3 plus on that side as well. So 2 plus 1 minus a minus makes a plus, plus 1 makes 3, and I've got 3 plus on that side, so that's balanced. Right, okay, now I want to combine this equation with this equation. Okay, because remember what a redox reaction is where you have one reaction undergoing reduction combined with another reaction undergoing oxidation. Okay, so how many electrons does this need to gain on this left hand side? It needs to gain 5, but every time an Fe2 plus reacts it only loses 1. So how many times will the Fe2 plus have to react to lose 5? Well, it will need 5 lots of this reaction here. So I'm going to times this reaction by 5. Okay, let's have a look at the overall equation then. So bring this one in together. So we've got MnO4 minus plus 8H plus 5 electrons plus 5 times Fe2 plus 5 Fe2 plus go to this top line, Mn2 plus 4H2O plus 5 Fe3 plus, I'm here, 5 Fe3 plus 5 electrons, 5 electrons. Okay, so that side of the equation is gaining 5 electrons, and there are 5 electrons on that side, so I can cancel those out. So my overall equation is MnO4 minus plus 5 Fe2 plus goes to plus 8H plus goes to Mn2 plus 4H2O plus 5 Fe3 plus. Okay, let's check that's balanced. Mn, yeah, 4 O's, 4 2's 8H, 4, 8, yeah, 5, that's good, perfect. Okay, so that equation there shows me that 1 mole of manganate 7, okay, manganate 7, that's where the naming comes from, manganate, it's manganese in its oxidation state of plus 7, and it's manganate because there's oxygen in the complex ion, so it's manganate, oxygen in the complex ion, you name things with 8. Okay, so manganate 7 going to Mn2 plus, okay, and then Fe2 plus going to Fe3 plus. So the manganate 7 is reduced, the manganese is reduced from plus 7 to plus 2, the Fe2 plus is oxidized from plus 2 to plus 3. That's it for today, and thank you for watching. Don't forget to like and subscribe and hit the bell notification to stay updated.